All right, so which property is illustrated in number 1? How do you know it's the associative property? No, do not say parentheses. Every one of these has parentheses. They were not all associative. Andy? Okay, the order stayed the same, but what was in the parentheses changed. Good. So you had 9 and 8 here and 8 and 4 here. So this is the associative property. All right, what about number 2? What about number 2? Why is that distributive, or how do you know it's distributive? Yeah, like the 3 gets handed out to everything, right? So it starts by having parentheses, and then there are no parentheses. So that's a distributive property. Okay, and then what about the last one? That's the commutative. Why? Yeah, the order of the numbers changed. Did what was inside the parentheses change? No, what was inside it here? 2 and 6. What was inside it here? 6 and 2. So same 2 numbers are inside the parentheses, but the order of them changed. So that is not associative, even though it has parentheses. So don't think just because you see parentheses that means the associative property. All of these have parentheses in it, but that only one is the associative property. Okay, so we have 2 lessons left this unit, and then you guys will have a review and a test next week. I think it's Thursday. That seems right. Yes, Thursday. You guys are going to go to work on Wednesday. So Monday we will do 1 more lesson. Tuesday we'll do a review and a Kahoot. And then Wednesday you guys will go to work. And Thursday you guys will have your test. Okay? Yeah. So your grades are in for your quiz. So if you are not pleased with them or have no idea how you got that one, please come see me during office hours, because you can retake it, but you need to go over it with me before you can retake it. Okay? Some of you guys, the average, I think, was almost a B, so pretty good. But I know some people are not going to be happy with their grades. So if you want to come see what you did on the test, you can come to my office hours. Again, my office hours are in the bullpen, not in here. So don't come here. If it's dark, I'm not here. That's because I'm in the bullpen. So that's downstairs through the gym, through the middle door. Okay? So that's where I am in the morning and at lunch. And then we'll do retakes after school on Thursdays. You can also do a retake at lunch or in the morning if you think a half an hour is enough time, okay? Like the quiz that you guys took before, you could probably do that retake at lunch because it wouldn't take that long, all right? It's not that long a quiz. Okay, so the last thing we're talking about this unit is kind of an introduction to functions. So a function is, does anyone know what a function is? Elijah? Okay, it involves input and output. Typically, it's an equation with variables, all right? And we're going to talk throughout this year about 3 different types of functions. We're going to spend most of first semester talking about linear functions. Then we'll talk about quadratic functions, and then we'll do a little bit with exponential functions. So there's 3 different types of functions. And what Elijah said is really important. There's an input and an output. So that's what we're going to focus on today. But before we do that, I want to do some basic stuff about coordinate planes because we're going to need coordinate planes. So this is a coordinate plane. Can you guys tell me what a quadrant is? What is a quadrant, Dejane? Yeah, it's like the 4 boxes, right? So this is a quadrant right here, made up of these little squares. This is a quadrant right here, this one and this one. And we say this is quadrant 1, I'm going to abbreviate it Q. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. All right, there are 4 of them because quad, that prefix, means 4. All right, Q-U-A-D means 4. Okay, so in quadrant 1, all of the numbers are what? Positive, so it would be plus, plus. In quadrant 2, what is it? Negative, positive, so negative x's but positive y's. In quadrant 3, what is it? Yep, everything's negative. And then in quadrant 4, positive x's, negative y's. Okay? So every one of these makes, laughing at that one? Because it looks like a face. Yeah? All right. Okay, so yes, it does look like a face. Okay, so all of these are what? What do you call those things with the parentheses and the comma? What is that thing? Coordinates or ordered pairs. Exactly. So that's a coordinate or an ordered pair. The first number in a coordinate is your x value, and the second is your y value. So all these symbols here just mean that x is positive and y is positive. X is negative and Y is positive. Both are negative, or X is positive, Y is negative. What is the X and Y? What is that? Where does X and Y come from? Jesse? The what? The lines, exactly. Which one is the x-axis? The horizontal line. So this right here is your x-axis. And then this right here is your y-axis. So the y's go up and down, whereas the x's go left to right. Yeah, across, exactly. So they go across, and then the y's go up and down. All right, what's the origin? What's the origin? David? 0. How many numbers are there? 0, 0, right? So you'd have two of them. So 0, 0. And origin means where it starts from. So everything starts at 0, 0. This is your origin, which has the coordinate 0, 0. All right? So the origin is 0, 0. How do you plot a point on the coordinate plane? Like if I gave you 5, -3, what would you do? What would you do? Jessica?
You would go positive.
From where?
From the origin.
Okay, we always start right at the origin. All right.
And then you count 5 cubes.
Okay.
And then since the big is negative, you go across.
Very good. So this is my x, and this is my y. And this tells me since it's positive, I'm going to move to the right 5. And then I'm going to move which way 3? Down 3. And how do you know it's down 3? It's negative. What if this were negative? Then you'd go left and then still down. Okay, so we're going to go over 5. 1, 2, 3, 4, 5. And down 3. 1, 2, 3. So that coordinate would be right here. 5, -3. What quadrant is that in? Quadrant 4. All right, and you see that the x is positive and the y is negative. How many of you guys have done this before? Good. All right. So if you have not done this before, that's okay. But most of you guys should have at least seen this before. Okay. All right. So I would like 4 people then to come plot M, N, L, and O. And I want some new hands. So Dejane do 1, Ray do 1, Yasmin do 1, and one more person. Pick any color you want, but just one person at a time. One more person. All right, Jessica. So which one are you going to do, Dejane? The first one? Okay, so you're going to do M at 8, 9. As Dejane does that, positive 8, positive 9 is going to be in which quadrant? Quadrant 1. It's going to be in the first one. So she's going to go over how many? 8 to the right, and then 9 up. Very good. So that one should be almost off the graph. I know it's really hard to see. I'm sorry. I need to get better coordinate planes. That looks good. 8. Yeah, perfect. Can you label it M for me? Good. All right. Good. Okay, so which one or ones, which of these do you think tends to be the ones that trip people up the most? What letters trip people up the most? N and O. Why do N and O trip people up? What do they have in common? They have a 0 in them. And for some reason, when there's zeros in them, people like lose their minds and forget what to do. Always remember this is your X, so that's what you do first. You go over first, all right? And then this is your Y. So you went over how many here in O? Did you go over any? No. So you didn't move over at all, and then you moved which way? Up 5. So you should just go straight up 5. So that's why O is up here on the y-axis, and N is right here on the x-axis. All right, this only has an x value, so it shouldn't move off of the x-axis. Okay, again, x comes first, y comes second. So you move over before you move up or down, and you always start from the origin. Always start counting from the origin. Okay, so if I want to identify the coordinates then, I want to identify P, Q, R, and S. How would I identify where P is? How do I know where P is? Who can tell me?
Look where Q's at on the x-axis.
Okay.
And then once you do that, look where it's at on the y.
Yeah, look where it is on the x-axis and then look where it is on the y-axis. So basically, how far over do I have to go to get to P? 3. I went 3 over. And then how many up? 1, 2, 3, 4, 9. Good, so that would be coordinate 3, 9. And again, that's in which quadrant? 1, very good. Okay, Q is in which quadrant? 2. And I went over how many? -3. And then how many up did I go? 2. All right, what about R? I went over -8. And then I went down to -6. So down 6, so I went down -6. What about S? +2, because I went to the right 2, and then -6. Very good. Okay, so ordered pairs are just ways to identify spots on the coordinate plane. So if you think about the coordinate plane like a map, an ordered pair is just a direction for where you go. So it tells you first you go right or left, and then second you go up or down. But ordered pairs don't just exist in a vacuum, all right? So what I mean by that is ordered pairs mean something. Every single ordered pair is an identification of an exact spot on a coordinate plane, and it can correspond with a lot of different equations. An equation is something that represents, like here we have an equation. How many variables does it have in it? Has 2 variables. This is a linear equation. That means this equation, even though it doesn't look like it right now, represents a line on the coordinate plane. And the line on the coordinate plane is made up of all the different x, y values that would work in this equation. So go back to what Elijah said at the very beginning, which is that a function has an input and an output. So what does he mean by that? What does input-output mean? What does input-output mean? Emmanuel? Okay, exactly. You replace the variable with the input. Input is what you put in, and then output is what you get out of it, right? So we think about functions like every machine that we have is basically an example of a function. So think about, for example, if you go to a water fountain and your input is that you press the button down, what's the output? Water comes out, exactly. If your input is I take cake batter and I put it in an oven, what do I get out? A cake. Something happens in the oven, and then there's a cake, right? And is the input-output, are they different things? Like think of the cake batter cake example. Are they different? No, not at all. So if I make you a birthday cake, Dejane, and I just give you a big old bowl of batter, did I make her a birthday cake? No. What did I make? I made some batter, but they're not the same thing. Are they made of the same stuff, though? Yes. So it's eggs, and because I'm lazy, it's cake mix and oil, right? So I'm not going to make it from scratch because I like you, but I don't have all that time, right? So I do something to it so that even though the ingredients are the same, has it changed? Yes. And that's what a function's doing. So that's what Emmanuel said. You put in an input for the variable, and you get an output. And that input-output is our ordered pair. So in this case, we've got 4 different inputs here, -1, 0, 1, and 2. All of these can fit into the equation. Where do we put our inputs? Replace it with the x, and our output is the y. So basically, all I'm doing is plugging in -1 in this equation. So instead of writing x, now I'm going to write what? What kind of math is this? Multiplication. So I'm going to put parentheses. So the first thing I do is 4 times -1, which is what? So -4 minus 3, which gives me negative 7. Very good. All right, negative 7. So then what's my ordered pair? Negative 1, negative 7. Because my x value is negative 1 and my y value is negative 7. All right, again, can you do this in your heads? Yes, by all means. Okay, if you can do that in your heads, go ahead. I would just be careful because a lot of times with negatives, people get confused. All right, so the next thing I'm going to plug in is what? 0. 4 times 0 is what? 0 minus 3 is negative 3. So then what's my ordered pair? 0, negative 3, because my x was 0 and my y is negative 3. All right, the next thing I'm going to plug in is what? 1. What's 4 times 1? Minus 3. Good. So my output is 1. So what's my ordered pair? 1, 1. And then the last thing I'm going to plug in? What's 4 times 2? 8 minus 3 is? Good. So what's my ordered pair? 2, 5. So that's my ordered pair. So we have negative 1, negative 7, 0, negative 3, 1, 1, and 2, 5. Are those the only inputs that you could plug in? No? What else could you plug in? 7. What else? Every single number, including decimals and fractions, right? So we could play this game forever. We're not going to, all right? I'm not usually going to ask you to do more than 4 or 5. But those are the ordered pairs. And the reason that we care about that is because all those ordered pairs can be put onto a coordinate plane. So I want to plot those onto a coordinate plane. So where do I go for that first one? Quadrant 3, I go left 1 and then down 7. Okay, and then the next one is y-axis. So I go over how many? 0 and then down 3. Okay, next one. Over 1, up 1, and then the last one. Over 2, up 1, 2, 3, 4, 5. Okay, now what does that make? A line. Oh, I did it almost. All right, so that makes a line. Good. Why do I put arrows on the end? Because it keeps going forever. Every single place on this line represents another what? Represents another ordered pair. Do we care about everyone on the line? No, because if we did, how long would we be here? The rest of your lives. And I know you all like algebra, but you don't want to be here for the rest of your life. So we're not going to make a list of all the ordered pairs, which is why we put what on the ends? Arrows, okay? So that's why you put arrows. David?
Why wouldn't you go left?
For which one?
For 0 and 3.
Because 0 tells me I don't move over at all. And then this tells me I move down. So this first number tells you over. Well, I don't move over at all, so I don't go left or right. And then the second number tells you I move down 3. Okay? So what type of function then do you think it is? If it makes a line, what type of function do you think we call it? Linear. This is a linear function. So all the functions we're going to talk about for pretty much the whole first semester are going to be linear, which means if you plot them, what will they look like? A straight line. So if you are doing it and you plot it and it doesn't look like a line, is it a linear function? No. Or you made a mistake. One of those two things. Okay? So if it looks almost like a line with one weird point, you probably made a mistake. But if it doesn't look like a line at all, then it's not a linear function. Because again, a function that creates a line is going to be a linear function. Okay, so let's try this one. What's going on in this one? Yeah, you can make your own inputs. So in this case, I want you to do how many? 5. I want you to do 5. You can make them. Should you do 200? No, why not? That's a really big number. So when you are given the choice to make your own inputs, should you pick huge numbers or small ones? Probably small ones. Should you pick whole numbers or decimals? Probably whole. What I am going to ask is that you always do 0, and that you always do some negatives and some positives. So you will always see me do these because they are the smallest that I can do, that are whole numbers, and I want to keep them as close to 0 as possible. Why do you think I want you to do 0? Why do you think I want you to do 0? Yeah, sometimes weird stuff happens at 0. It's also easy, right? If you plug in 0, it typically is a pretty easy one to do. So I like it because it's easy. But it also, sometimes weird things happen at 0, so you want to see that on a graph. Okay, so if I plug in -2, what kind of equation does this have? I'm sorry, what does it have in it? Yeah, it has an exponent in it. So I'm going to do my first one, 2 -2 squared plus 1. What do I do first here? Okay, what's -2 squared? It's in parentheses, because whenever you plug something in, you've got to keep it in parentheses, because the whole thing has to go in. So what's -2 squared? 4. So I'm going to do 2 times 4, which is what? And then plus 1 is 9. So my ordered pair would be -2, 9. All right, the next one I'm going to do, what's -1 squared? 1. So what's 2 times 1? Plus 1? 3. All right. What's 0 squared?
0.
Good. What's 0 times 2?
0.
Plus 1?
1.
Good. All right. What's 1 squared? Times 2? Plus 1. And last but not least, what's 2 squared? Plus, or times 2? Plus 1. Do you notice anything before we even go to plot these? What do you notice? What do you notice? Yeah, there's some kind of pattern happening, right? Like there's some pattern happening in the x's and the y's. So we're going to go and we're going to plot this on a coordinate plane. So -2, 9, -1, 3, 0, 1. I'm just trying to remember this. -2, 9, -1, 3, 0, 1, 1, 3, 2, 9. Okay. So -2, 9 is going to be over -2, up 9. -1, 3 is going to be right here. 0, 1 is over nothing at all, and then up 1. 1, 3 would be right here, and 2, 9 would be right here. I'm going to connect those. Is that a line? No? So is that a linear function? No, that's not a linear function. Does anyone know what this is called? What? It is nonlinear. That is one way to describe it. Go back to the equation. What was different about the equation? Had an exponent, so we call this an exponential function. All right, this is called an exponential function. And it's called exponential because it has the word exponent in it. It has an exponent in the equation. All right, it's an exponential function, and it makes a parabola. Has anyone heard the word parabola before? All right. Say parabola.
Parabola.
Okay, parabola. It's not parabola. It's not a disease. It's parabola. Okay, parabola. All right, and a parabola just means that it makes a curve, like a U. We are going to do most of our exponential functions in the second semester, but I want to give you guys an idea. So when you see that, you know, is it linear? No, it doesn't make a straight line. Okay, it makes a U or a V, depending on how you look at it. Okay, what's happening here? There's a what? Absolute value, right? There's an absolute value there, which means that all of my y's should end up being positive. So no matter what my x's are, my y's should be positive. So I'm going to plug it in. Negative 5 plus 3, what does that give me? Negative 2, absolute value is 2. All right, I'm going to do these mentally. Negative 4 plus 3. Negative 4 plus 3. Negative 1. Negative 1 absolute value. Positive 1. Negative 3 plus 3. 0. Absolute value of 0 is negative 2 plus 3. 1. Absolute value of 1 is 1. And negative 1 plus 3. 2. Absolute value of 2 is 2. Very good. Okay, so my ordered pairs are negative 5, 2, negative 4, 2, negative 3, well, not 2, sorry, 1, negative 3, 0, negative 1, 1, and negative, nope, oh my gosh, 1, 1, and 2, 2. Okay. Do you think this is going to make a line? Did I do something wrong? Yes. Thank you. This is negative 2, 1, and this is negative 1, 2. Okay. Do you think this is going to make a line? Maybe. Maybe not. Okay, so let's plot these. Our first one is negative 5, 2. All right, negative 5, 2, so I go over negative 5 up 2, negative 4, 1, negative 3, 0, negative 2, 1, and negative 1, 2. All right, did that make a line?
Well, not that.
No, how many lines did it make? It almost makes 2 lines. This is called an absolute value function because it has an absolute value in the equation. All right, and it's going to make a V, because it kind of starts at a spot and shoots off in both directions. And the reason for that is because, like you guys said at the beginning, the y is always going to be what? If it's an absolute value, the y is always going to be positive. So if the y is positive, that means it can't cross down here, which is why it kind of like bounces off, okay? It doesn't actually bounce, but imagine it were a laser, then it would bounce off, all right? It has to stay positive. So this is an absolute value function. Okay, so for your practice, there are 4 of these. You guys are doing all 4. You're completing the tables before you move. You don't have to copy the whole tables. You can just write the y values. Okay, so you can just write y equals and give me the 5 values for y. But you're plugging in the numbers that are given.